the MSI Unify X and 8200 CU DIMMs from G-Skill. This is the Trident Z5 CK. These are CU DIMMs. Turns out the secret to unlocking the Arrow Lake performance is CU DIMMs, and it can make it quite a bit faster. Let's take a look at CU DIMMs on the Unify X, which the Unify X is 2 DIMMs, 1 DIMM per channel. This is the fastest DDR5 option motherboard. And, well, I mean, if you know the Unify, you know MSI's Unify X line is all about overclocking and all that kind of stuff. And you know that I don't typically know life overclocking, but I have written a little guide on the things that I found that worked well for me. And it did move Shadow of the Tomb Raider performance from 270-ish FPS to over 300 FPS. And you can also improve the memory latency pretty reasonably. Actually, to be clear, you can make the memory latency go from over 100 nanoseconds to 60, but in order to get the memory latency below like 75-ish, you have to disable things that make the cores actually go fast. So you could have fast memory, but not fast. We'll get into it. Let's take a look. So I put this system together in the studio, and the thing that I like best about our MSI 360mm cooler is that it comes pre-assembled. I can take it out of the box and mount it. We will be overclocking, we will be coloring outside the lines, but it turns out Arrow Lake has extra layers of safety to try to prevent you from damaging it. That might be holding the performance back somewhat, and so because of that, I don't know that I'm encouraging you to make these changes. I think that if you make some of these tweaks, and yes, it does increase performance, but it could increase the chances that we have a situation where your CPU would degrade over time. Now, to be clear, any degradation that it does have is going to be completely 100% totally different than the degradation experienced by the 13 and 14900K, if for no other reason than the components of these CPUs, the Arrow Lake CPUs, were manufactured at TSMC, not Intel. It's a fundamentally different process, different node, different literally everything. Also want to say that the Scatterbencher has a nice write-up that is useful. You can read it and understand the parameters. Some of the variables you can change, some of them you can't. But the things that go against conventional wisdom when you're working on an Intel build is generally Intel builds don't really care as much about the memory speed. I mean, it cares a little bit, but it doesn't make dramatic performance differences. That is not really true anymore. Like, on Arrow Lake, the memory subsystem matters a lot for overall performance. Because of this tile, because of this tile design, that also means there are certain frequency sweet spots, and so you can find the sweet spots. Here's the other thing that defies conventional wisdom. That 5.7, 5.8 gigahertz max boost P, you forget about it. In most of the scenario, like 90% of the scenarios that I tested, you were better off having your P cores run at like 5.5, maybe 5.6, but nowhere near 5.7 or 5.8, because it seems to be the case when you run your P cores pretty hot, it chews up the power budget for everything else. So yes, you can get the P cores to run that high, but it's going to hurt performance of literally everything else, which makes gaming performance worse. Interestingly, overclocking the entire rest of the chip, E-cores, the ring frequency normally is 2.1 gigahertz. It seems pretty easy to get that to go at 3.5 gigahertz, 3.2 gigahertz, upwards of 4 gigahertz if you bump the voltage a little bit. That's in the write-up, but we'll talk about that. But first, let's take a look at our MSI Unify X motherboard. You got 6 10 gigabit Type A ports, a flash BIOS button, a clear CMOS button, and a smart button. I wish those weren't so close together, even though the CMOS button is just a little bit different than the other buttons. It's really easy to accidentally hit the wrong one, and then you've cleared your CMOS, and then what did I do with that overclock? Below that, you got 4 USB Type-C ports, but they're all different. You got a 10 gig Type-C, 2 Thunderbolt 4, that is 40 gigabit Type-C ports, and then a USB 10 gigabit Type-C. If you want to think of the Thunderbolt ports as USB 4, you can. USB 4, Thunderbolt 4 in an Intel context, same thing basically. Then you've got your PS2 mouse and keyboard, which is great for Model M users that want to rock the original PS2 connector. 5 gigabit LAN, then you've got 2 USB Type-A ports, 10 gigabit, your Wi-Fi 7 connections, analog line out, microphone in, and optical SPDIF out. This is the holy grail of rear I/O layouts as far as I'm concerned, just because of the number of Type A ports and the number of Type C ports. There are 2 PCIe 5x16 slots, 1 PCIe 4.0 by 16 slots. Those are physical. Electrically, you can run by 8x8x4. Then there's also one PCIe 4.0 by 1 slot. There is one M.2 Gen 5 slot and 5 M.2 Gen 4 slots. And then for the front panel, we have one Type-C and dual 10-pin. So you could have 4 more Type-A ports on the front panel, plus also the Type-C port, which is a great layout. Everything is toolless. So releasing this heatsink, which covers 4 of our M.2, pretty easy. You've also got an M.2 at the front edge of the board, as well as your Gen 5 M.2 that's above. Now the heatsinks on this are smaller, so I'm using the Crucial T705, it runs hot. The flat heatsink for the Gen 5 M.2 maybe on that T705 is a little much. Now in terms of the BIOS, let's take a look at the BIOS features. So if you're familiar with MSI BIOSes for the Arrow Lake generation, they have revamped the GUI in their BIOS, which is neat. So you got your flash, and you really want to update your flash every chance you get. Well, if you're building your system for the first time, you really want to check your BIOS and update the BIOS version. It is almost certainly different. There's probably a newer BIOS than the BIOS that your motherboard shipped with. And even though I've installed the 8200 because I've just installed the memory, it came up at 6400 mega transfers, 48 gigs. So that's dual 24 gig DIMMs. These are, just sort of the things you can check. You can also see the core frequency and voltage. One really awesome feature of this BIOS is if you didn't get your CPU cooler on correctly, the BIOS will pop up and say, hey, the CPU's running a little warm, it's unusual, which is awesome. Get easy mode and advanced mode. Of course, we're going to go to advanced mode. You got full control over the different gens of PCIe. If you're running Samsung M.2, you may want to check out native ASPM and disable it, and PCIe ASPM, and you can configure which of your PCIe Express root ports. This doesn't necessarily map to a physical slot or a particular M.2. It's actually easier to use Linux to see which root port maps to which M.2 slot. I might do that later in the forum or whatever if we have a lot of inquiries or it's really popular. A lot of people pick up this motherboard. But ASPM is kind of power management. It saves power, and it's good because more power budget means that you can put that power budget somewhere else. But Samsung M.2s are famously bad about going to sleep and waking up. They're almost borderline narcoleptic. And that can hurt performance and throw errors in your Windows event log in the operating system. So you can disable that. It's OS controlled. And there's also PCIe native power management, which you can disable, which makes it completely invisible to the operating system. Generally, I don't recommend disabling PCIe power management unless you're having a problem or unless you have one of the M.2s like Samsung that have that problem. Got all the standard configuration. If you're having the blue screen on a fresh Windows install with the GPU, you can come in here and disable the IGD multi-monitor, but there is a BIOS update to fix that. Thunderbolt configuration, if you're having problems with resized bar, or you've got peripherals that use a lot of bar space like an RDMA network card, you may end up having to disable PCIe or USB 4 because of resource allocation. Just be aware of that. There's some screenshots on the forum. I would refer you there because you're gonna, stopping and rewinding and going through a bunch of videos really is super annoying. And probably I will have learned stuff from the time that I did this video, and so that thread on the forum being updated is important. But MSI performance preset, Intel default settings, MSI performance settings. Basically, it's like 347 amps to 400 amps. This is a minor bump. This should be safe. I didn't tell you that officially. Overclocking, you're taking your hands into your own life, but this should be reasonable, especially if you've got good cooling. And then you've got some more presets. And these presets do have, you just toggle it on and then, oh, look at that, gaming performance is better. The most important thing you can do is turn on XMP, which we haven't done yet, and we'll talk about in a second. But the next thing is when you're messing with all of this. Advanced CPU configuration, you can configure things like, let's turn off all of our P cores but one, and turn on all of the active E cores. Disabling E cores doesn't do anything for you, at least not right now, not really. And that is what it is. Like in the past, that might have made a difference on 14, but on Arrow Lake, it doesn't. It actually hurts things. So don't do that. This processor also supports running your AVX ratios a little less than everything else because AVX still is a power virus on Intel's design, and they still will clock the processor slower. That's fine, perfectly reasonable. Here's where you enable the extreme memory profile, so I'm going to set that to enabled. It is going to run in Gear 2. We're going to start at 8200. I'll tell you that one of the uncanny valleys of all of the ratios lining up is around 7200, but 8200 is achievable with this kit because I've already experimented with it. MSI also has their memory try-it, which is really useful. DDR5 7200CL34, you can load that, and hey, maybe the ratios there will make sense, and your CPU will run better with that than, you know, 8200 with worse timings. VNN AON voltage. It is 0.771 volts by default. I've experimented with up to 1 volt. This is also covered in Scatterbencher's documentation, I believe. And setting it to more than 0.77 volts, like 0.85 or 0.95 volts, meaning that you're able to move that 2.1 gigahertz ring frequency up to more like 3.5 toward 4.0. That does make some benchmark numbers go up, but generally doesn't dramatically improve gaming performance, interestingly. So looking at Ada64, I mean, it's hard not to get excited for these results. I mean, look at this, 115 gigabytes per second and a 2-DIMM configuration platform. Why is the gaming performance not face melting? 87.5 nanoseconds latency is really, it's not dramatically different than 65 nanoseconds we were getting out of the box on 14900K, but the memory bandwidth is something else. You can see we're going through literally all of the combinations to try to get memory latency a little lower, down to 83 nanoseconds with 3100 NGU and 4100 for your ring frequency, which is the 1 volt that I was telling you about, like the VNN voltage boost from 0.77. So what don't I like about the Unify X? Well, keep in mind it's only 2 DIMM slots, so memory capacity. Theoretically, someday you could do 128 gigs on this platform, but 96 gigs is possible right now. That 8-pin power input at the bottom edge of the motherboard? Yeah, that guy knows what I'm talking about. That's not great because it's going to block a second video card, but you're not going to run a second video card anyway. There's no physical buttons on the motherboard for powering it on, but you can set the smart button on the back to do that, or set the smart button on the back to take you directly to BIOS, or use that and the overclock button in clever and creative ways to boost things here. So there we go, that's a quick look at the MSI Unify X, and you probably can achieve similar performance on not a high-end motherboard like the MSI Unify X, but having the stuff in there, if you like tweaking things, you could definitely do that. I was surprised that I was able to move it over 300 FPS in Shadow of the Tomb Raider and see similar uplifts in a lot of games, but not every game. The performance of this CPU is definitely odd compared to, and really, probably not even really comparable, I would say, to prior gen Intel CPUs because it's fundamentally put together a different way. This is kind of the new normal. Now the other unspoken part of this is if you aren't looking to play at 300 FPS at 1080p, a lot of this doesn't really matter too much. You can have a perfectly reasonable gameplay experience at 1440p and 4K. You're much more GPU limited in those scenarios, and this CPU can definitely feed the beast. Its multi-core performance is quite good. It's better than the 14900K for rendering, Blender, etc., etc. If you pick up the i5, there's not as many cores to go multi-core, but the best core on these CPUs is really probably the E cores, not the P cores. The E cores are absolutely monstrous. They really are. Interesting look at the MSI Unify X. Interesting look at G-Skill's new 8200 CU-DIMM kit. I'm Wendell, this is Level 1. I'm signing out. You can find me in the Level 1 forums. If you want to run something on this, let me know. Hit me up in the forum. Let's chat. Alright, I'm signing out and I'll see you there.